Good morning. On the last period we have started semiconductor. There are two types of semiconductors. What are semiconductors? The substances whose electrical conductivity is greater than insulators but less than conductors. The elements in fourth group of periodic table such as silicon and germanium contains 4 valence electrons. All these 4 valence electrons are covalently bonded with 4 valence electrons of neighboring atom, and no any electron is available for current conduction. Therefore, at 0 degree Celsius, such substances act as insulators. But at room temperature, some of covalent bond breaks and some of electrons are available for current conduction and act as semiconductors. There are two types of semiconductors. Intrinsic type semiconductor, a pure semiconductor which contains only one type of atoms in fourth group of periodic table, is called as intrinsic type or pure type semiconductor. In this semiconductors, electrons are available for current conduction due to only breaking of covalent bonds, but current conductivity of such substances is very small. To increase current conductivity of semiconductor, some impurity atoms is added. In pure semiconductor, the semiconductor formed by doping some impurity atoms in pure semiconductor is called as extrinsic type semiconductor. A semiconductor which is formed by doping some impurity atoms in pure semiconductor is called as extrinsic type semiconductor. Depending upon doping, there are two types of semiconductors, that are p-type semiconductor and n-type semiconductor. If trivalent impurity is trivalent impurity, if small quantity of trivalent impurity which is present in third group of periodic table and contains 3 valence electrons such as boron, aluminum, indium is added in pure semiconductor, then a semiconductor formed is called as p-type semiconductor. Here, impurity atom contains only 3 valence electrons. Impurity atom contains only 3 valence electrons, and all these 3 valence electrons are covalently bonded with 3 valence electrons of neighboring atom. This impurity accepts electron from neighboring atom and produces positively charged empty space, which is equivalent to electron, called as positively charged hole. Thus, if one trivalent impurity is added, which produces one positive charge, if large quantity of such a pentavalent impurity is added, then large number of positively charged are available or produces in semiconductor, and resulting charge on that crystal becomes positive, and hence it is called as p-type semiconductor. Means in p-type semiconductor, number of protons, means number of positively charged holes are very greater than number of negatively charged electrons. One more type about n-type semiconductor. If pentavalent impurity present in fifth group of periodic table contains 5 valence electrons such as arsenic, antimony, phosphorus is added in pure semiconductor, then n-type semiconductor is formed. This impurity contains 5 valence electrons. Pentavalent impurity contains 5 valence electrons, of which 4 valence electrons are covalently bonded with 4 valence electrons of neighboring atom, and 1 electron is directly available for current conduction. Means pentavalent impurity donates electron for current conduction, and hence it is called as donor impurity. Trivalent impurity accepts electron and produces positively charged holes, and hence it is called as acceptor impurity. In this case, number of electrons is very greater than number of holes. Means there are two types of semiconductors, that are p-type semiconductor and n-type semiconductor. Now, today we have to see about p-n junction diode. Today we have to see about p-n junction diode. p-n junction diode. When p-type semiconductor, suppose this one as p-type semiconductor, see here p-n junction diode. When p-type semiconductor is connected to n-type semiconductor. Suppose this one as p-type semiconductor, which contains majority of positively charged holes. P-type semiconductor contains majority of positively charged holes like this. When p-type semiconductor, n-type semiconductor contains majority of negatively charged electrons. N-type semiconductor contains majority of negatively charged electrons. When such a p-type semiconductor is connected to n-type semiconductor, then the resulting semiconducting device is called as p-n junction diode. It has two electrodes, means positive electrode and negative electrode, therefore it is called as diode. Di means two electrodes. It has two electrodes, positive electrode and negative electrode. This is called as p-n junction diode. What is p-n junction diode? When p-type semiconductor is connected to n-type semiconductor, then resulting semiconducting device is called as p-n junction diode. It has two electrodes, that are positive electrode and negative electrode, therefore it is called as diode. आता होतं काय पहा, when junction is formed, then sum of positively charged holes from p region enters in n region. Sum of positively charged holes from p region enters in n region, and sum of electrons from n region enters in p region, and thus opposite charge layer म्हणजे या बाजूला पॉझिटिव्ह, सॉरी या बाजूला निगेटिव्ह पोटेन्शियल, तर या बाजूला पॉझिटिव्ह पोटेन्शियल. Thus small opposite potential is developed across junction. This potential is called as barrier potential. This potential is called as barrier potential, and such opposite charge layer is called as deflection layer. See once more. When such a p-type semiconductor is connected to n-type semiconductor, then sum of positively charged holes cross the junction and enters in n region. At the same time, some of negatively charged electrons cross the junction and enters in p region. Thus, opposite charge layer is formed at junction. This layer is called as deflection layer, and small opposite potential is developed, called as barrier potential. This barrier potential, in case of germanium, this barrier potential is about 0.3 electron volt, and in case of silicon, this barrier potential is about 0.7 electron volt. म्हणजे इथे जे पोटेन्शियल तयार होतं त्याला म्हणतात barrier potential. Small opposite potential is developed across this junction. This potential is called as barrier potential. In case of germanium, this barrier potential this barrier potential is about 0.3 volt, and in case of silicon, this barrier potential is about 0.7 volt. आता हा जंक्शन डायोड सर्किट मध्ये कनेक्ट करत असताना आपल्याला दोन प्रकारे कनेक्ट करता येतो. एक म्हणजे फॉरवर्ड बायस पीएन जंक्शन डायोड सर्किट मध्ये कनेक्ट करत असताना दोन प्रकारे करता येतो. एक म्हणजे फॉरवर्ड FORWARD फॉरवर्ड बायस्ड जंक्शन diode, and one more, that is reverse biased junction diode. जंक्शन डायोड सर्किट मध्ये कनेक्ट करत असताना आपल्याला दोन प्रकारे कनेक्ट करता येतो. एक म्हणजे फॉरवर्ड बायस आणि दुसरं म्हणजेच रिव्हर्स बायस. फॉरवर्ड बायस, suppose this is our PN junction diode. Suppose this is a PN junction diode like this. Here the P-type semiconductor, N-type semiconductor. Suppose this one as PN junction diode. In P-type semiconductor, positively charged holes are majority charge carriers. In N-type semiconductor, negatively charged electrons are majority charge carriers like this. Small opposite potential, called as barrier potential, is developed. म्हणजे या बाजूला negatively charged polarity किंवा चार्जेस, या बाजूला पॉझिटिव्ह चार्ज. ह्याला म्हणतात बॅरियर पोटेन्शियल किंवा ह्याला म्हणतात डिफ्लेक्शन लेअर. समजा इथं जर आपण हा सिलिकॉनचा पीएन जंक्शन डायोड बनवला तर या ठिकाणचं जे पोटेन्शियल आहे, स्मॉल पोटेन्शियल डेव्हलप्ड इज called as barrier potential, and which is in case of silicon, this potential is about 0.7 volt. If p-type semiconductor is connected to positive terminal of cell and n-type semiconductor is connected to negative terminal of cell, positive ला negative ला, positive negative, then such a type of biasing is called as forward biasing. What is forward biasing? If p-type semiconductor is connected to positive terminal of cell and n-type semiconductor is connected to negative terminal of cell. Positive, positive, negative, negative, then such a type of biasing is called as forward biasing. In this case, समजा इथं अप्लाय केलेलं पोटेन्शियल आहे V इज इक्वल टू सपोज 0 व्होल्ट. 0 व्होल्ट पोटेन्शियल असताना समजा बॅरियर पोटेन्शियल आहे 0.7 व्होल्ट. सिलिकॉनचा असेल तर इथं 0.7 व्होल्ट असतं. हा त्याचा डिप्लेक्शन लेअर आहे. इफ बायसिंग पोटेन्शियल, ह्याला म्हणतात बायसिंग पोटेन्शियल. इफ बायसिंग पोटेन्शियल इन्क्रीजेस, समजा या ठिकाणी आपण हे बायसिंग पोटेन्शियल सी, इफ सपोज बायसिंग पोटेन्शियल V, करंट I, आपण ग्राफ कसे प्लॉट करतोय, बाय करंट फ्लोइंग थ्रू दिस डायोड विथ पोटेन्शियल. 0 पोटेन्शियल असताना करंट हा 0 असतो. As biasing potential increases, as forward biasing potential increases, positive असल्यामुळे positive charge holes shifts towards junction. At the same time, negatively charged electrons shifts towards junction. In case of forward biasing, पॉझिटिव्हला जोडल्यामुळं जसं आपण हे फॉरवर्ड बायसिंग वाढवतो, इन्क्रीज करतो, तसं पॉझिटिव्ह चार्जेस जंक्शन कडे शिफ्ट होतात. दिस पॉझिटिव्ह चार्जेस शिफ्ट टुवर्ड जंक्शन एज वेल एज नेगेटिव्ह चार्जेस शिफ्ट टुवर्ड जंक्शन means majority charge carriers shifts towards junction and therefore width of deflection layer decreases. These majority charge carriers shifts towards junction and hence width of deflection layer decreases. म्हणजे जसं आपण हे पोटेन्शियल वाढवत जातो लाईक दिस, इथं 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, जसं आपण हे पोटेन्शियल वाढवत जातो तसं हे मेजर चार्ज कॅरी जंक्शन कडे क्रॉस होतात, जंक्शन कडे शिफ्ट होतात. width of deflection layer decreases and if applied potential is about 0.7 volt then deflection layer becomes 0. Width of deflection layer becomes 0 and if applied potential is greater than 0.7 volt, if this potential is greater than 0.7 volt, then negatively charged electron cross the junction and attracted towards positive terminal. At the same time, positively charged holes cross the junction and enters in towards negative potential. Means beyond that barrier potential, charges directly flows through junction and therefore current flows through circuit. Means beyond that current flows through circuit like this. And graph of IV characteristics is like this. परत पाहिजे काय काय सांगितलं. What is forward biasing? What is forward bias PN junction? If p-type semiconductor is connected to positive terminal and n-type semiconductor is connected to negative terminal, then such a type of biasing is called as forward biasing. In this forward biasing, as applied potential increases, majority charge carriers shifts toward junction. Width of deflection layer decreases. And if applied potential is greater than the barrier potential, then majority charge carriers cross the junction. Means electrons cross the junction and attracted to positive terminal, and positively charged holes cross the junction and attracted towards negative terminal. Means if applied potential is greater than barrier potential, then majority charge carriers directly cross junction and hence current flows. Means beyond that barrier potential, current is directly proportional to applied potential. This is about IV characteristics of junction diode, forward biased junction diode. Reverse bias. If suppose this one as junction diode. Suppose this one as junction diode, P-type semiconductor, N-type semiconductor, like this. Here positively charged majority charge carriers, positively charged holes, here the negatively charged electrons are majority charge carriers. इथं हा डिप्लेशन लेअर म्हणजे या बाजूला निगेटिव्ह चार्जेस आणि या बाजूला पॉझिटिव्ह चार्जेस. When p-type semiconductor is connected to negative terminal of cell and n-type semiconductor is connected to positive terminal of cell. फॉरवर्ड मध्ये पॉझिटिव्ह पॉझिटिव्ह निगेटिव्ह निगेटिव्ह, फॉरवर्ड मध्ये पॉझिटिव्ह पॉझिटिव्ह निगेटिव्ह निगेटिव्ह. इन केस ऑफ रिव्हर्स बायसिंग पॉझिटिव्ह निगेटिव्ह निगेटिव्ह पॉझिटिव्ह. If p-type semiconductor is connected to negative terminal of cell and n-type semiconductor is connected to positive terminal of cell, then such a type of biasing is called as reverse biasing. What is reverse biasing? What is reverse biasing? If p-type semiconductor is connected to negative terminal of cell and n-type semiconductor is connected to positive terminal of cell, then such a type of biasing is called as reverse biasing. As reverse biasing increases, graph off, इथं आपण काय करतो, निगेटिव्ह पोटेन्शियल अप्लाय करतोय, करंट I. If reverse biasing potential increases, समजा आपण हे पोटेन्शियल इन्क्रीज केलं, if reverse biasing potential increases, then positively charged holes attract towards negative terminal and negatively charged electrons moves towards positive terminals. Means majority charge carriers moves away from junction. In reverse biasing, majority charge carriers, majority junction, and hence width of deflection layer increases. ही width अशी वाढत जाते. In case of reversing biasing, in case of reverse biasing, as reverse bias potential increases, majority charge carriers shifts away from junction. No any charge flows through junction, and therefore such a conductor or such a device acts as off. In this case, majority charge carriers directly cross the junction, therefore acts as on state. Reverse biasing off. Why? Because majority charge carriers shifts away from junction. No any charge flows through junction and acts as off. Means current does not flow through junction, and hence even if negative potential increases, current through junction is zero. जंक्शनचा करंट हा झिरो असतो. बट ॲट अ पर्टिक्युलर पोटेन्शियल, आपण इथं पोटेन्शियल वाढवतोय, बट ॲट अ पर्टिक्युलर पोटेन्शियल temperature of this device increases. At a particular negative potential, temperature of this device increases, and covalent bonds breaks suddenly. Covalent bond direct break होतात and large number of positive and negative charges develop and these charges flows through junction and current suddenly increases. Means even if negative potential remains constant, current increases suddenly. The negative potential at which current increases suddenly is called as breakdown voltage. The negative reverse potential at which this structure breaks. PN junction diode breaks and current suddenly rises is called as breakdown potential. What is breakdown potential? If reverse biasing potential increases, then at a particular potential, diode structure breaks. Means covalent bond breaks and suddenly electrons are available for current conduction which flows through junction and hence current increases. Means diode structure breaks. That negative potential is called as breakdown voltage. This is about forward and reverse biasing. Means in forward biasing, diode is on state. In case of reverse biasing, diode is off state. Means whenever current passes through circuit, junction diode must be in forward bias. म्हणजे जर समजा आपल्या सर्किट मधील करंट जर तयार करायचा असेल, पास करायचा असेल, तर तो डायोड हा नेहमी फॉरवर्ड बायस मध्येच असावा लागतो. दिस इज अबाउट फॉरवर्ड बायसिंग अँड रिव्हर्स बायसिंग. खरं तर एवढा पूर्ण भाग आपल्याला 11th ला झालेला आहे. म्हणजे पीएन जंक्शन डायोड, फॉरवर्ड बायसिंग, रिव्हर्स बायसिंग, IV कॅरेक्टरिस्टिक्स ऑफ फॉरवर्ड बायसिंग, रिव्हर्स बायसिंग ह्या सर्व तुम्हाला 11th ला झालेल्या आहेत. याच्या पुढचा भाग आपल्याला 12th मध्ये पाहायचा आहे. ते म्हणजेच युजेस ऑफ डायोड. याचा पुढचा जो भाग आहे तो खरं तर आपण 12th मध्ये पाहणार आहोत. युजेस ऑफ डायोड. ओके. Next part on next period.